Hi, thank you for joining us. In this video, we will learn about the benefits of relationships in Timbr's knowledge graph, how they work, and how to use them in SQL queries to reduce query complexity and speed up all data activities. So let's jump in. In this example, we'll work with a simple data model containing just three concepts. The first concept is people. If we take a look at the data from the table that was mapped to this concept, we can see it includes people's IDs, names, cities, phone numbers, and ages. The next concept is calls. Here, we can see that the map table has data of call IDs, device IDs, call time and date, caller and callee numbers, as well as the call duration time. The third and final concept is devices. In devices, we can see that the data is mapped to a table that consists of IDs of the people who own the devices, the type of devices, for example, a smartwatch, smartphone, or computer. And we can also see each call ID made by each individual device. Normally, if we would like to query data from all three tables, we would need to join the tables, which could result in an exhaustive query depending on the data and structure. With Timbr, however, we can simply create relationships between the concepts and use them to automatically join data from multiple tables, or in our case, concepts. So let's see how it's done. We'll create a relationship between people and devices based on a related column between them. Once we're done, we'll add two more relationships from people to calls, highlighting the semantic difference where a person in a call can be either the caller or the callee. Once the three relationships are set, we will be able to traverse the graph and generate complex queries seamlessly. So let's start with creating the relationship. We'll right-click on Concept People and select Edit Concept. Now, let's head over to the Relationships tab. Here, Timbr automatically suggests relationships. In our case, let's go ahead and create a relationship from scratch by clicking on New Relationship. We can see that there are different types of relationships depending on the data and requirements. If you want to learn more about the different types of relationships, you're welcome to explore our YouTube channel where you can find videos on each type of relationship and how to best put it to use. For now though, we'll continue with our standard relationship. We'll give the relationship a direct name looking from people to devices. We'll call it HasDevice. Next, we'll add an inverse name going from devices back to people. We'll call it OwnedBy. Now, we'll select the target concept, which will obviously be devices. And finally, we'll choose a property from the people concept to match with a property from the target concept devices. In this case, it will be person ID for both. Once selected, we'll click on Save, and once more on Save Changes to save and add the relationship. And there it is. We'll now move ahead by quickly adding the two additional relationships from people to calls, and we'll continue from there. Great. So if we now take a look at all the relationships connecting our concepts, it should look like this. We can see the relationship connecting people and devices, as well as the two relationships added connecting people to calls, each with its own semantic meaning, a caller and a callee. Great. Let's jump over to Timbr's SQL editor, where we can now start to leverage these relationships we just defined. In the SQL editor, or any other SQL endpoint connected to Timbr, we choose to query the dtimbr schema, which is Timbr's virtual schema that exposes the knowledge graph concepts, including their relationships. We'll start with the people concept. We'll select the person's first name, age, and city. Now, we can scroll down the metadata and access device data using the HasDevice relationship we have defined in Concept People. Let's go ahead and request the device type. Finally, we'll write the from on the dtimbr schema and query the people concept and run the query. And there it is. Timbr automatically joined the tables according to the relationships and returned our results. To understand what this query did and how the relationships were translated, we can click on the Explain Query button, and here we can see the join conditions and query structure that Timbr pushed down to the database connecting the people and devices tables. To really emphasize the simplicity, let's take another example. We'll copy the previous query, though this time we'll travel once more from people to calls using the relationship made call, asking for the call duration. Now, when we run the query, we can see the call duration data was added as well. And if we click on Explain Query, we can see that another join was added to the query once we added the call property. Finally, let's make things a bit more interesting and take one step further. This time, we'll choose the calls concept as our starting point. From concept calls, let's select the call IDs, the caller numbers, and the callee numbers. Now, let's access the people concept using the caller relationship and choose the caller's name. Next, we'll use the relationships of the people concept to access concept devices data, as we don't have a direct relationship between calls and devices. We'll do so by using the hasDevice relationship of people and request the device type. Let's also do the same for the callee. We'll take the callee's first name, and we'll travel again starting from concept calls to people to devices, requesting the callee's device type. Finally, we'll keep the Timbr schema, but we'll change the concept to calls and run the query. And there it is. All the data from the tables was joined automatically. With just a couple lines of SQL, we used Timbr to formulate a relatively long and somewhat logically challenging query fast and in a simple and intuitive manner. One small thing to mention is that Timbr's default behavior is to perform a left join. Therefore, the results may show null results. If we'd like to remove the null results by performing an inner join, we can simply add a where statement on the specific column, being that it is not null. Great. So once again, when clicking on Explain Query, we can see how our 3-line query has turned into an 18-line query with multiple joins needed to connect the different tables. This is how Timbr transforms complex queries into simple, easy-to-use queries so any user at any level can gain insight fast and with minimal effort. I hope you enjoyed this video. Thanks for watching and have a great day.